Hello, everybody. My name is Mr. Cantor, and this is Modeling with Mr. Cantor. Today, we're going to be looking at Explore Part B. Now, what I want you to do is to please pause this video, read this question to yourself, and then we will read it together. All right, welcome back. This story reads, Diego and Andre are both in a summer soccer league. During the month of August, Diego has a game every third day, starting August 3rd, and Andre has a game every fourth day, starting August 4th. So this question wants us to predict whether the problem involves finding common multiples or finding common factors. Explain your reasoning. Please pause the video and let me know. What do you think the difference is between common multiples and common factors? All right, welcome back. If you said common multiples sounds like multiplication, and so therefore we have to list multiplication tables for certain numbers, then you are correct. And if you said common factors requires us to divide numbers and break numbers down into their little components, into their factors, then you are correct as well. Now, in this question, there are certain words here that can really point us in the right direction as to which type of question this is. All right, what I want you to do is to please pause this video. Can you find those words and let us know which words are helping you predict what type of problem this really is? All right, welcome back. If you said the words every in this story is making you think this is a common multiples problem, then you are correct. Now, in this context, the word every is used to show repetition. Specifically, both athletes have ongoing games in the month of August. Since there's repetition and common multiples sounds like multiplication, and multiplication was designed to show repeated addition, then this is definitely going to be a common multiples problem. Now, there's actually another really big clue in this story that shows it's a common multiples problem, and many times it is overlooked. And that clue is the numbers themselves. We can notice that we're talking about the number 3 and the number 4, and both of those numbers are very small and actually don't have many factors in common. In fact, the only factor they do have in common is the number 1. So therefore, if this was a common factors problem, it would be answered very quickly and there wouldn't be much for us to do. So therefore, it only makes sense for this problem to be a common multiple question. So let's see. This was the story. Now let's see what the actual question is. Here we go. Please pause the video, read this question to yourself, and let me know, what do you think you need to do? All right, welcome back. Let's read part A together. Part A reads, what is the first date that both boys will have a game together? What type of question is that? Please pause the video and let me know. All right, welcome back. If you said that is a least common multiple question, then you are correct. Momentarily, we will find the least common multiple and solve this. Let's look at part B. It says how many of their games fall on the same date? All right, that's going to be answered as well once we find the least common multiple. All right. So please pause this video. I want you to make a list of multiples of 3 and make a list of all the multiples of 4. All right, welcome back. If you said the multiples for Diego for the number 3 is 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, you are correct. And for Andre, if you said the multiples of 4 are 4, 8, 12, 16, 20, 24, and 28, you are also correct. Good job. So let's actually answer the first question from part A. They want to know, when will both boys have a game on the same day? Well, if we find the LCM, we will know the answer to that question. Please pause the video and let me know. What do you think is the LCM for 3 and 4? All right, welcome back. If you said the LCM is 12, then you are correct. We can clearly see here that 12 is the first number or the first day that both Andre and Diego will play a game on the same day. Excellent. So our answer to part A is, what is the first date that both boys will have a game? That answer is on the 12th day of August. Now, interesting fact here is, for Diego and for Andre, for the 3 multiples and for the 4 multiples, we actually stopped at number 30, and here we stopped at 28. Why do you think we did not keep listing multiples? Because there's a lot more multiples for 3, and there's a lot more multiples for 4. Why do you think we stopped? Please pause the video and let me know. All right, welcome back. If you said we stopped because the month of August has 31 days, So realistically, if we added another multiple for 3, we will be at 33 days, and there just isn't 33 days in the month of August. In addition, if you said the reason why we stopped at 28 days for Andre is because if we added another 4, we would be at 32. And there is not 32 days in the month of August. So therefore, we had to stop at 30 for the multiples of 3, and we had to stop at 28 for the multiples of 4. Good job. Right. With that said, let's move on to part B. It asks us how many of their games fall on the same date. Well, we know for sure that they will both play on August 12th, but are there any other days where they will both play on the same day? Please pause the video and let me know. All right, welcome back. If you said they will also play on the 24th, then you are correct. 24 is a multiple of 3, and it is also a multiple of 4. Therefore, we know that the 24th of August, both of these athletes will be present playing soccer in the Summer Soccer League. So essentially, on the 12th day of August, they will both play a game together on the same day. And for part B, 2 games will fall on the same date in the month of August, the 12th and the 24th. All right, let's take a look at the next story. Please pause the video, read the story to yourself, and then we're gonna do a 3 reads activity. All right, welcome back. This story reads, during a performance arts festival, students from elementary and middle schools were grouped together for various performances. There are 32 elementary students and 40 middle school students. The arts director wants identical groups for the performances, with students from both schools in each group. Each student can be part of only one group. All right, that was the first time we read this story. Now, the first read asks us, what is the situation about? Please pause the video and let us know. What do you think the situation is about? All right, welcome back. If you said this situation is about an arts director who wants to make different groups for a performance, you are correct. And there's a lot of different answers you can come up with here. This is just one of them. All right, so we're gonna read the story again, and this time we're gonna focus on the different quantities in the situation. Please pause the video, read the story one more time, and let me know, what are some numbers you see here? All right, welcome back. If you said that there are 32 elementary students, that is a really important quantity in the story, and you are correct. If you also said there are 40 middle school students, that is also a very important quantity in this story. All right, I want you to read this story one more time, and this time specifically focus on what kind of questions do you think they might ask us in this situation? All right, welcome back. If you said in this situation, they might ask us how many groups can be made or how many students will be in each group based on this story, then you are correct as well. Now, you might have noticed in the previous example, the numbers that we had were actually very, very small and had very limited factors in common. In this case, you will notice that 32 and 40 each have a lot more factors, and they might even have many factors in common. So what type of question is this starting to look like? Please pause the video and let me know. All right, welcome back. If you said this is starting to look like a greatest common factor problem, then you are correct. Now, one of the reasons why this is a greatest common factor problem is because it mentions a very specific keyword. And that keyword is groups. Now, in this context, the word group is used to show splitting up a quantity, specifically our total number of students, which will be divided to make identical groups. Once you see that you are dividing, splitting, making some kind of a grouping, you are talking about greatest common factor. So let's summarize. If you spot the following words, every, smallest, least, both again, chances are we're talking about multiples. And if you spot the words groups, split, maximum, greatest, chances are we're talking about factors. Please write this chart down into your notebook so that you can be prepared the next time you see one of these types of stories. All right, my name is Mr. Cantor. Thank you so much for watching this video. I will see you in the next one. Goodbye for now.